Prove that this trig identity holds for theta not equaling these values, and hence otherwise show that tan 15 degrees is 2 minus root 3, and solve for x between 0 and 360, this trig equation here. So I've written everything out above. So let's have a look at the first part then, part A. Now let's simplify these in terms of theta then. This is 1 over 2 sine theta, cosine theta, isn't it, using the double angle formula for sine 2 theta. So let's put that in. Minus, now you'll see that the denominator is the same, so we can just put this as the denominator, common denominator, minus cos 2 theta, and that's equal to 2 cos squared theta minus 1, isn't it, or 1 minus 2 sine squared. So I'm going to put the 1 minus 2 sine squared theta in so that the 1's will cancel. And let's see what we get then. That's equal to, the 1's will now cancel, we'll get plus 2 sine squared theta on the top, because a minus and a minus is a plus, over 2 sine theta cosine theta. And now the 2's will cancel as we wondered. And one of the sines will cancel here. And it's just going to leave sine theta over cos theta, which is tan theta, provided that these conditions hold, of course, because we can't divide by 0. Part B, hence or otherwise, show that tan 15 is equal to 2 minus root 3. So here, theta equals 15 degrees gives, and that's a valid input. So we can work out tan 15 then, can't we, reading it from right to left, of 15 degrees is equal to 1 over sine of 30 degrees, because it's 2 theta, minus cosine 2 theta, which is 30 degrees, over the sine 2 theta, which is 30 degrees again. So this is equal to 1 over a half, which is 2. This is root 3 over 2. 3 over 2 divided by the half, which turns out to be root 3, doesn't it? So that equals 2 minus root 3, which is what we wanted to show. And then we need to solve this trig equation, cosec 4 theta minus cot 4 theta. Oh, equals 1. So cosec 4 theta is 1 over sine, isn't it? 2 theta. And cos 2 theta over sine 2 theta is cot 2 theta. So here we see that cosec 2 theta, this is part 2 then, so if we put x equal, let's just write it, this should be cosec 4x, shouldn't it, here. So in part 2 then, let's put theta as 2x. Cosec theta equals 2x. Theta equals 2x gives, and then we'll get cosec 4x, won't we, for 1 over sine 2 theta minus, and then cos over sine is going to be cot 4x, and that will equal tan of theta, which is tan 2x, equals, and then we can replace that by 1. So tan 2x equals 1 is the problem then. And we're solving this for x between 0 and 360. So again, I need to slightly amend the question that I've written. So, so tan 2x equals 1 then for x between 0 and 360. We're solving this equation for x between 360 degrees and 0, aren't we? Tan 2x equals 1. So here, that's between, 0 and 360. So 2x will be between 0 and 720. So let's let y equal 2x, and then we've simply got to deal with tan y equals 1. And we know that that will need to be solved between 0 is less than y. Double this, that's the y. Double this is 720 degrees. So there's our problem then. So let's draw a circle. Whoops, let's right cast. Tan is positive, isn't it? 'Cause it's 1 here and here. Draw 2 lines. Mark off the alpha to the horizontal then, and simply write tan alpha equals 1. So that tells us then that alpha is equal to 45 degrees. So there's our angle. So the first solution then. So the first solution, which is y, which is 2x, is equal to, or let's put y, leave it as is at the moment. So y is equal to, the first solution is round to here, which is just 45 degrees. And then the next solution is round to here, which is 225, isn't it? 180 plus 45. And then the next solution, because we're going right round twice, we go round once and round again. So that's 360 plus 45, which is 405 degrees. And let's go round once more. So that's 540 plus 45 is 585, isn't it? Because 3 180s are 540 plus 45 is 585. So that's 2x. So that implies then that x equals 22.5 degrees. 112.5 degrees. I'm just halving them. 202.5 degrees. And this 58.29, 290, 2.5, 92.5 degrees. So here's our solutions, aren't they? In the required range, because x goes, well, y varies from 0 to 360. 0 to 720, and these vary from 0 to 360, which they do.